Hello everyone, how are you? I am Akrash, your teacher here, and I will teach you different questions and their answers. So I welcome you on class3.com. So our today's question is N2F2 N has a hybridization of sp2 while F has hybridization of sp3 or sp3 hybridized because they carry three lone pairs of electron each and are bound to one atom only. The nitrogen atom are each attached to two other atoms and have one lone pair, so they both have a strategic number of three electrons. Groups are as far as part of possible, then they are in a trigonal planar arrangement. A trigonal planar arrangement of electrons produces bond angles of 120. However, we work that the angles will be compressed by about 2 for the lone pair on each nitrogen atom, giving us 118 for both bond angles. Is the bond angle correct? And am I talking about the CAS from N2F2 or the transform? And what is the molecular geometry of the molecule? And the answer of the question is, let's address the each part of question regarding N2F2. First, bond angle. You mentioned bond angle of 118 degrees for N2F2. This angle is indeed plausible for difluorodiazene. In difluorodiazene, each nitrogen atom has a lone pair of electrons, which cause some compression of the bond angle from ideal 120 degrees. Due to lone pair repulsion, the actual bond angle is N2F2 is approximately 118 degrees, considering the lone pair repulsion and the resulting geometry around each nitrogen atom. Second, CIS or transform. N2F2 can exist in both CIS and transform. In the CIS form, the fluorine atom on the same side of NN bond, leading to a bent molecular geometry. In the transform, the fluorine atom are on opposite side of the NN bond, leading to a linear molecular geometry. To determine whether you are discussing the CIS or transform, you would need to specify the relative positions of the fluorine atom with respect to the nitrogen bond molecular geometry. The molecular geometry of N2F2 depends on its structure. CIS France, bend geometry, bond angle less than 120 degrees. Transform, linear geometry, bond angle 180 degrees. In both cases, each nitrogen sp2 hybridized because it is bonded to two other atom and has one lone pair. Therefore, based on the formation provided, the bond angle is approximately 118 degrees. Is correctly for difluorodiazene. Whenever you are discussing the CIS or transform, depends on the relative position of the fluorine atoms around the NN bond. The molecular geometry of N2F2 can be the bent or linear depending on the arrangement of the fluorine atoms. Thank you for watching the video. If you have any question related to this video, please post a comment below. If you have any question in your mind, you can also post on the website and I will be answering you in the next video. Thank you for engaging with us. Until next video, bye bye.